So are events A and B independent? We're flipping two coins, and event A represents obtaining tails, on the first flip. Event B represents obtaining tails on both flips, so tails twice. And for this question, I'm actually going to use the sample space of flipping two coins. We can either get heads and heads, heads and tails and heads, or tails and tails. So 4 possibilities here with our sample space. Okay, so remember that the condition for two events to be independent is that the probability of event A and B is going to be equivalent to the probability of events A times event B. So what is the probability of A and B in this case? The probability that it's tails in the first flip and that we get 2 tails. Well, that's just going to be 1 out of 4. Because if we're getting both tails in the first flip and tails twice, that just means that we're getting tails twice. Does that make sense? Hope so. The AND, of course, represents that they both must happen at once. And if they happen at once, it must mean that they're obtaining, or we're getting tails twice. So now, what is the probability of A, just obtaining tails on the first flip? Well, we have 2 possible outcomes here. We have this one, obtaining tails and then heads. Then we also have this one, obtaining tails then tails. So that is 2 out of 4. 2 out of 4 possible outcomes. So just half, of course. Then finally, what is the probability of obtaining tails twice? Well, it can only obtain tails twice in one way out of 4 ways. Okay, so this simplifies to 1 out of 2. 1/2 times a quarter. 1 times 1, 1. 2 times 4, 8. Oh, look at that. 1/4 is equal to 1 over 8? No. So these events are dependent. The occurrence of one affects the probability of the other. And we have proven that just because PA and B is not equal to PA times PB. So that's the ultimate test right here. If we could show that they were equal, they would have been independent. That's it.